All right, good evening. Here is the topic 1 review for linear functions and systems. I'm going to go ahead and go right in order here. Our first question is topic essential question. What are the different ways in which functions can be used to represent and solve problems involving quantities? Now for this vocab section, I'm just going to write like little notes here. All right, just like write little pictures off to the side here. And that should explain it, so I'll draw little pictures. But really this question, the whole point of this topic is that we saw that we can, the connection between graphs and equations and tables, inputs, outputs, how we can transform equations so that the graphs look a particular way, so it models a certain situation. All right. We saw linear inequalities, linear systems, graphs, their intersections as solutions. Just all of that basically is connecting. The whole point was to connect equations with graphs and tables. All right. So something like that would be a fine answer. So if you put graphs, tables, equations, transformations, stuff like that. All right, for number 1. Now number 2, the blank pairs every input in an interval with the same output value. So essentially what that means is every time you put in an input, okay, every time you put in something, it gives you the same. The next one, still the same. The next one, still the same. Now if you did it here, okay, that's a step function, all right, because you basically, over subintervals, you're just going to have the same value as an output, so that's a step function. Number 3, the point at which a function changes from increasing, okay, it's increasing, to decreasing is the blank of the function. Now of all of these here, I hope that you're eyeballing the minimum or the maximum, and clearly we have a mountaintop here, right? We have the top of a hill, so this guy would be considered a maximum. Okay. Now, if we ended up decreasing and then increasing, well, then this guy here is the bottom of a well, or bottom of a ditch or something, right? So that would be a minimum. All right. So that's the difference between those two. Now, number 4 says a blank of a function y equals a times a function that has x minusing h plus k is a change made to at least one of the variables a, h, and k. Now, we worked with that like a lot. All right, we can change the a so that the graph changes. We can change the h inside the parentheses, means that the function moves right to left. If we change the k, that is, if it's outside the parentheses, we know it'll move up and down. So a makes it like the graph tighten, or if the a is between 1 and 0, if it's like a fraction or a decimal that's less than 1, then it'll actually widen. So those are all transformations. All right, we can transform the graph to the way that we need it. A blank is the value when y equals 0. So if y equals 0, that's another name for the x-axis. So when you have values that actually hit y equals 0, those are actually the zeros of the function. In fact, that is why we call them zeros. Okay, so these are zeros of the function. And then finally 6, a blank is defined by 2 or more functions, each over a different interval. Well, the ones that have different intervals are the ones that look like this, right? So if they have different intervals, then, and it's still the same function, that's going to be a piecewise function. All right, move on to the next video.